Here W1 is a vector space in which every element is a 4 coordinate vector, and each of these elements u, v, w and x are the real numbers which are connected by these three relations. We can write these three relations independently down below. Now when we solve these three equations, we find that actually there are only two of the linearly independent equations. That means equation number 2 and equation number 3 can be used to obtain equation number 1. Therefore, out of these three equations, only two of the equations are linearly independent, which implies only two of these four coordinates will be linearly independent. So we take u and v as linearly independent, and on solving these equations we obtain the following form of this vector in terms of u and v. Now since u and v are assumed to be linearly independent, we can assign them values in the following way. First we put u equals 1 and v equals 0, then we obtain and then we put u equals 0 and v equals 1, and this gives obviously these two vectors are linearly independent, and also this set is the basis set for this given vector space, and from this we can see which clearly shows option number 1 is not true. For option number 1 says dimension of W1 is equal to 1, but we can see it is 2. Now the same way we determine the dimension of vector space W2, which is given again. We have a set of these three equations which we write again. On solving these three equations, we can easily find that and we can take u as the linearly independent coordinate. So we can write any element in this vector space W2 in the following form. Also we can assign u any arbitrary value, so we can take u equals 1 and we obtain also this set is the basis set for vector space W2, which consists of only one vector, therefore dimension of W2 is equal to 1. Also this shows if option number 2 is not true. For option number 2 says dimension of W2 is equal to 2, which we can see is not 2 but it is 1. Also now we can see that the basis set for vector space W2 consists of a vector which is linearly dependent upon one vector of the basis set of vector space W1. Therefore dimension of W1 intersection W2 is equal to 1, and so option number 3 is true. Also option number 4 is not true, for we can see on putting the values of dimension of W1, dimension of W2 and dimension of W1 intersection W2, we obtain which is not equal to 3 as given in option number 4. Therefore option number 3 is true.